All right, welcome back. We're going to do our second proof here in geometry. This one has to do with this diagram here. And as you can see that our proof has to do with angles. Okay? Our last proof was dealing more with the segments in the diagram. Okay. All right, so something that I want to point out right here is that every proof question is going to involve a given statement and a proof statement and usually a diagram. Now the nice thing is that this kind of gives us our starting point and our final destination, right, in our proof. Right? You can see how this given statement shows up at the top of the left column, and the word given shows up as the first reason. And then also our proof statement shows up at the very bottom of the statement column. Okay, so it's kind of like a sandwich where we have the top bun, we have the bottom bun, and we need to fill in all the ingredients in the middle. All right. So we know that angle AEB is complement to BEC, right? So AEB, maybe we should color these in. Okay, so AEB, that orange angle, and BEC is that green angle. Okay, so they are complements of each other. Well, if we see one of our vocabulary words, we might want to think about what it means. What is its definition? Okay. So complementary angles are angles that add up to 90. So maybe that's what goes on the next line, right? Maybe I need to write that the measure of angle AEB plus the measure of angle BEC equals 90 degrees, right? That follows directly from the word complement. I'm just using the definition, and oh yeah, look, there's the reason. Definition of complementary angles. Okay. All right, our next line says the measure of angle AEC is equal to the measure of AEB plus the measure of BEC. So where is AEC? AEC is that pink angle right there. Okay, so what this is saying is that the big angle in pink is equal to the sum of the smaller angles, the orange and the green. In other words, that the two smaller angles that are next to each other add up or sum up to the bigger angle. We have a name for this. This is called the angle addition postulate. Okay. Two smaller angles next to each other will add up to form some bigger angle. Okay? And that's what this equation is saying, right? The big angle pink is equal to the sum of the smaller angles, the orange and green. All right, next it says that the measure of angle AEC, that's the pink one, equals 90 degrees. Okay, well, I wonder how they got there. If I look at line 2, it says the measure of AEB plus the measure of BEC equals 90 degrees. And on line 3, I have one of those expressions again, right? The measure of angle AEB plus the measure of angle BEC, right? But I know that those two things already add up to 90 degrees, so I can do a substitution. I can replace this expression here with 90 degrees. Okay. So we're just doing a substitution. Okay. We're substituting this expression here on the left with this expression here on the right, but we're just doing it in a different equation. Substitution property. Okay, the next line is completely done for us. The measure of angle AED plus the measure of angle AEC is equal to 180. Okay, so maybe I need to use yet another color. So angle AED is this one right here. Okay, so this is basically saying the blue angle and the pink angle add up to 180 degrees. That makes sense because those angles form a linear pair. Okay, they are next to each other at the same intersection point or the same vertex. All right, line 6. I don't know the statement, but I do have a clue that I need to do some kind of substitution. Well, line 4 tells me that these two expressions are equal, measure of angle AEC and 90 degrees. And on line 5, I have one of those expressions, right? Measure of angle AEC. All right, so I can swap one expression for the other. Right? So I'm going to replace this with 90 degrees. Measure of angle AED plus 90 degrees equals 180 degrees, right? So I'm just substituting this expression for that expression in line 5. Okay. And then the final statement is what we're trying to prove, that the measure of angle AED, which is the blue angle, is 90 degrees. And so if I look back at my previous statement, I can see that if I just subtract 90 degrees from both sides, then I'll end up with what I want. Okay. So, I mean, I can write it here like minus 90, but all you need to do is just write subtraction property. Of equality. Okay. If it helps you, you can write it out, minus 90, kind of like what you would do in an Algebra 1 class when you're solving an equation. But technically, you don't have to write that out. You do just have to write what you're doing, right? You're subtracting, and then you can just do that part in your head. All right, so there is our second proof of the course. This one was a proof about angles. Remember, the first proof we did was about segments. And stay tuned, we're going to do a few more proofs.